This
Now
conference will now be recorded.
discuss about the 3.1. So what is replication controller? So replication controller have a two feature. Okay, one is like replication, that means you can get a many pods in one go, because once you deploy the pod you get only one pod. Okay, so if you want too many pods, similar kind of pods, then you have to replicate. And this controller, you say like I want 10 pods, so Kubernetes will make sure that always 10 pods, not 11, not 9. So that is a replication controller. How do we work with it? Let me show you. So replication controller example DevOpsSchool. So you can take this one, some code from here, and let me show you the code. What do you want? Replication controller. What is the name of it? Rajesh RC. And then how many replicas you want? 5 pods. And this is the container for each pods. So let me create it. So here, how many replicas you have in the default RC? See, replication controller, you don't have it. So rc.yaml and save it, run it, kubectl create -f rc.yaml. See, kubectl get rc. See, 5, correct. Now if you see the pods, see these all pods created by replication controller. That's all. So you want more pods, so kubectl scale, there is a command for scale. You can edit also, but I'm not teaching you traditional. You can edit the RC the way I taught you earlier, like this, if you remember, but I'm not covering it. Remember that this command you can apply for any resources, but I'm covering some automated command which will help you to understand this one. So I don't remember the commands exactly, so -h, and here this is the simplest one. So kubectl get rc. Here how many you want? Let's say 20. And what is this? RC, name of the RC is Rajesh RC. Are you guys able to hear me, right? Hello,
Yes, yes.
someone got out, I guess.
Yeah, Anshita looks like.
Anshita, yeah. Okay, so should we wait for her?
Yeah, I'll check once.
Just, yeah. So
This
now
conference
if you
will
look
now
at
be
this,
recorded.
see here, I replicated. Now I'm going to replicate 20 pod. See, now you got this 20 pods. See, if you get pods, see, this is a replication. And there's one more feature we have, a this one is called controller. So right now I'm replicating to 2 pod. So you see, rest of the pods will get deleted. See, terminated. So it's very powerful, but we are not using this one, but you need to know actually. See, now we have 2 pods. Now I'll show you the control. Look at this age, 3 minutes, 3 minutes. So kubectl delete. See, I'm manually deleting the not RC pod. Why? Because I want to show you the controller feature. See, I deleted manually. Accidentally, it can happen. And you see, new pod got replaced. So this is the power of uh, replication controller. So in a nutshell, yes, replication controller, using that you can create a multiple pods, and also whatever the pod you set initially, Kubernetes will always run that number of pods. That's called controller feature. Understood now?
Yeah.
Now what is the deployments? So deployments has 5 features. Which are the features? So you have a 2 features here, replication and controller, but also you have a one feature which is called versioning. That means whatever that you deploy, keep deploying multiple version of image, right? Through same deployment. So it will do the versioning in built-in Kubernetes. Okay, and then you have a rollout, means you can upgrade to the, let's say, 1.1 image to 1.12 image without single second downtime, without single 1 second downtime, without downtime. So this is like a rollout, and rollback also you have that one. So if you want 1.2 to 1.1 without downtime, so that is a feature you have with the deployment only. That feature you don't have in the replication. So these are the primary feature, 5 features you have for the deployments. Now let me work with the deployment through the command line. Okay, so for that, all these commands, by the way, you have it, and tutorials just like I'm following, right? You should spend some time. So here, Kubernetes deployment and DevOps school. Okay, now if you see, this is the one. You can multiple, you have it, just spend some time, you'll get it. So here you see replication, controller, versioning, rollout, rollback. So you have all 5 feature. Now you have a complete detailing also. Okay, I want you to spend some time with this because that's important. Now what I'm going to do, I'm going to show you the directly commands for the deployment. So how do we deploy? Look at this here. Before that, you know what, I will delete this rc, kubectl get rc, kubectl delete rc, name of the rajesh rc. I deleted rc. If you delete, everything's gone. And there's one pod also, right? I will delete that pod also in the default namespace. So kubectl delete pod, and name of the pod is this one. Gone. So I clean this clustered in the default. Nothing is there, you see. So now do we have a deployment? So kubectl get a deploy shortcut. Okay. See, you don't have any deployment in the default namespace. So I'm creating it. Look at this command. I'm directly using it. Create deployment, name of the deployment, and is from the same image. Remember, version 1 image, and how many deployments? 3 pod. So you got this deployment now, and kubectl get pods. If you see 3 pod, you got it. So you see that one feature which is called replication. That means you can get as many pods you want. You want to scale it up, so same command you can use, and you want to scale 10 pods, let's say from 3. See, there's some issues with the command actually. This is the problem, space issue. Okay, so 10 pod, and now see 10 pod you got it. So this is the replication feature we have in deployment also. Now let me show you the controller feature also. So see, right now we have 10, and now manually if I delete 1 or 2, see what will happen. So remember, I'm deleting 1 pod, 2 pod, 3 pod accidentally. Let's say 1 node is down, 3 pod is got offline. And what will Kubernetes will do? You see, look at this age, created 3. So this has a controller feature also. Are you understanding, guys? All of you? All of you? Hello,
So with the
Patrick?
for deployment, like I mean, there is a bit confusion to differentiate the replication and the deployment. Is it all about like the feature deployment is all about replicating, or how is
Yeah.
it like?
So
What is
deploy,
the
don't
diff?
go for that. Okay, okay. Don't think that the deployment which typically we use in the our software domain with this deployment. In this deployment, you deploy the pod, multiple pod. But at the
Mm.
same time, whatever the pod you deploy, it will be managed by, it will be controlled by Kubernetes, that number of pods. Okay. But
Mm.
extra features you have for this versioning, rollout, rollback also.
Okay.
Patrick, are you there?
Yeah, yeah.
Yeah. Okay. So this is the controller feature. I just showed you the controller. Okay, now I'll show you the versioning feature, how it's versioning. So anything you deploy, automatically version will happen. So which command which can tell us like versioning? So let me show you this command. You have to run this command, all this in a line, okay, slowly. But right now I'm explaining it to you. So see here, this is the revision number 1. That means I deploy only one. There is no change in the deployment. Now I'm going to make a change. So what we'll do, I'll make a change for an editing this deployment command. You know that edit here. See, editing this deployment live, because I deploy through command line, so I have to edit live. Now what I'm doing actually here, I'm changing the image. So v1 to v2. Now this image I have developed and put it in the hub actually already for the demos like this. So v1, v2 images are there. Okay, so I modify v2. Remember, and see here, rollout history. See, so this is like versioning, automatic versioning is happening. Okay, automatic versioning is happening. So whichever the images you change, automatically you have a here DevOpsSchool version 2, this is the DevOpsSchool version 1 image, so automatically Kubernetes will do that for you. Okay, so that is a thing. Now I want to show you, when you roll out from the one image to another, then without a downtime also it can do, and rollback when you do also, you without a downtime. How can you do that? So let me show you one field which is important for you. That's called rollout strategy. Okay. So kubectl get deploy. This is the name of the deploy. kubectl describe deploy and name of the deploy. See, this spelling mistake actually. Describe. What is this?
Yes.
So see, you should spend some time reading each and everything. Go slow, understand, because you are just building the understanding. But my focus is right now only these two. This one. Sorry, my bad. This one and this one. Two things. Strategy type and rollout update strategy. So first you look at this one. So deployment type, you can call it a deployment type or deployment strategy. So in the general computing world also, do you know what are the deployment strategy we use in the SRE? All of you, this is a fundamental question.
No, there is. I am not aware of any such terminology.
Have you heard about the canary kind of stuff? Blue
No.
green canary? No, you should know actually. All of
Blue,
you should.
green.
So do one thing. Search recordings will be there. Run the deployment strategy DevOpsSchool. Okay, and see here, this will come. And here all the popular strategy which we practice in the world, we have here. This image is a good one. Recreate, ramped, blue green, canary, alpha beta testing, shadow. And what you have here, you have a complete detail. But by the way, this is documentations also. Please spend some time over this. Good content. You will have a benefit, because if you want to become SRE without deployment strategy, it's just a waste of time. Okay, so understand that. Now coming back to the points here, Kubernetes deployment also have a supported strategy type, but only two. Which are those? So there's one is called rolling update and another one is called recreate. Okay, what we have, rolling update and recreate. Will you remember? Two strategy is been allowed by Kubernetes deployments. Okay,
Mhm.
so now you will ask, okay, what is a rolling update, what is a recreate? So let me explain it to you. So you go to this tutorial, go to the top. I ask you to read it, but I'll explain you some of it. And here, see here, type of deployment in Kubernetes, deployment, rolling update, and create. Now let's understand through images. It will be easy for you. So this image, the one which you see, this one is a recreate. Oh, sorry, rolling update. This is a rolling update. This image you see is rolling update. Okay, what is happening? So here we have deployed 3 pods. What is the version of pod? 1.1, 1.1, 1.1. Now you want to change the image, correct? You want to upgrade that image, you want to deploy something else, correct? So what do we do? So when you have a rolling update, I repeat, which is the default one. Let me show you again. Look at this strategy type, rolling update. It's a default one. By default, when you create a deployment, rolling update. This will make sure that no downtime. So what will happen when you select the type rolling update, which is a default, then see your desire is how much? 3 pod, correct? So here you see they will delete 1 pod and they will same time they'll create 1 pod of new version. So anytime 2 plus 1, 3. Then next time they'll delete 1, add 1, delete and 1. So this way, any given point of the time, you have a 3 pods and your customers is never seeing any downtime or something. Got it?
Okay. Yep.
So this is called what? Rolling update. Please remember, this is the most important question for the interviews also. Now next one is recreate. Let me show you the images for this. Recreate. Recreate is like you will have a few seconds of downtime, but sometimes you want to do the clean deployment, then you use the recreate. What is happening? Look at this. There is a deployment which you have a 3 pods, 1 version. Now when you select the recreate, it will delete the all the existing one and recreate the whole thing. Simple. Make sense?
But there will be downtime.
Of course, few seconds will be downtime, right? And as long as that it will create and then um, it will resync to the end user, correct? No?
Yep.
Few seconds. So like that. So please remember these two concepts. You have to practice it also through my notes. Everything has been detailing with the commands and all. Okay, so now by default we use the rolling update. Okay, so that's one. Now what is this? So when you have a rolling update strategy, then on what pace you want to destroy the pod and add the pod, that is a strategy. So here it says, hey, add a 20, delete 25% and add 25%. Simple. You can put the number of pods also, but this is standard actually 25, 25. So yeah, always remember. So now what to do? So I'm going to roll out to the new image. So I'll do the fresh because I will delete that one. So I will delete the old one, okay, because I don't need that one. Kubectl get deploy, delete and deploy and done. Okay. Now guys, I'm going to do fresh. So where is my commands? Rollout. See, I'm deploying the 15 pods. Remember, 15 pods. And you see, and immediately you should run this command, which will to the history 1, and then immediately you should check the status command, and it's so fast. Now you see replicating 6 pods, 7 pod, like that. That's the reason I deployed 15 pods. That way you can see the progress. Right now it will be very fast if you have a multiple worker, but unfortunately I have one worker just for the learning purpose, so it's going slowly, and it's a good for us because we see that status. Okay, now if you see that rolled out completely. Now kubectl gets pod, you have a 15 pods running with you. You look at the age, all are 35 seconds. That means same time it got deployed. Make sense, all of you? Okay,
Yep.
so now what I will do, roll out I will do to what? To next version, and which I did in the previous also. Create, edit, edit, here it is, and go to the image change, and now v2, save it, and you see immediately go to the status. See, now it's updating the container, updating the pods actually. See, look at this, they are doing in the batches, 25, 25, 25, remember? Termination updating, like that. Okay, done. Now can we see that status is done. And now can you see the history also? See, now I want to show you the pods. QCTL gets pods. Look at the age difference. See here, it's happening in the batch, correct now? 25%, 25% like that. Okay.
Yep.
Okay.
So
So
this
guys, this
uh,
let me show
one
you the
question.
upgrade.
Yeah.
Uh, Wait. Let me show you the upgrade. Remember, last image, V1 image, it was showing you welcome to DevOps School version 1. Now, if you do,
Mm.
this is a new image. See, version 2. Correct?
Yeah.
Now I want to roll back. I want to roll back. How can we roll back? So this is the, see, you have a 2 version right now. Look at this. So let's say this is the bad deployments. It's having some bugs. So I want to roll back this command and revision number 1, enter. And you see, slowly, if you see the status rolling back to the older one. And so now why we have a versioning here in the cluster, because it's easy for you to roll back instead of going for the whole codes and all. You can directly do that roll back at the cluster level. And if you see gets pods, let's get the pod. And now if you see rollback is completed, call http data, say v1, it will roll back successfully, correct? Understood now?
Yep.
So it has a 5 feature and which we need it. So remember, all this time this you have to do peacefully, at least 2-3 hours you do until you grasp complete thing. So replication, controller, versioning, rollout, rollback, everything it has been explained with the commands. You can follow this. Okay, so now with that, last service which I want to talk about is uh,
One question, sir, I have. When
mhm,
you did that deployment, uh, can you please get the command again, the deployment command?
mhm.
I wanted to see like where do you mention the image name, like with
Oh,
the
image
deployment
name.
command?
It's
Huh.
a, it's a, it's the same command. By the way, it's the same pattern. Here is the image name.
Mm-hmm. Oh, okay. You okay.
And second time when I modify, no,
Mm.
I edited and it
Okay.
directly.
In the deployment file you edited.
Yeah,
Okay. The
directly
version.
online.
Mm. Okay.
V2 I
Okay.
made it through the edit command. First
Mm.
deployment I did through the create command.
Okay. Yeah, makes sense.
Got
Yeah.
it?
Thank you. Mm.
Okay, so now the last one, which is I'm helping you with that service. So see, deployment was good, but you have to make these pods available for someone, right? So end user you have to deploy, correct? And
Mm.
this is the most important topics I'm putting in a some simple way, but you have to focus. If you're not understanding, please call out for questions. Okay, Anshita, Patrick.
Yes.
Okay, so now see, this is your cluster. Okay, this is your cluster. And now you may have a multiple worker theoretically, but for example, I'm using the 2 worker right now for the easy. Now there are multiple deployment you do. Some deployments typically, understand that I'm helping you to a small level. Typically what happens, this is the end user, Okay, this end user will hit the DNS, and DNS will go to the external load balancer, and external load balancer will go to the web server, one of the web server. There'll be too many web server. So here too many web servers will be there. 1, 2, 3, 4, 5, 6, 7, 20. Then it will go to the one more internal load balancer, and this is a web, okay, and this is a multiple machines will be there. App server. These are the VMs, or it can be pods in our case, okay, and this is the internal load balancer. And now this is the app, and then again probably one clusters of database will be there. I'm not complicating database, I'm putting the only DB part. Okay, so this if you see, this is outside, and this whole thing's inside. Okay, understand that? Are you understanding, all of you? Inside a network. Are you understanding?
Yep.
This has to be outside. Why? Because that's only the user will be able to connect, right? If you keep it inside, you'll not be able to connect. But between this load balancer and the web server, you have to create a proxy somewhere. Correct now?
Yep.
So this is something which we typically, it's a very small architecture. So now coming back to the Kubernetes. So in the Kubernetes, let's say there are multiple service we have. So service which is, in this case, service which is accessible to the public, okay, pub, and service which is application which is accessible to the public, or application which is related to the private. Okay, that is the thing, private and public. So right now I'm discussing this one. Let's say you have application which you want to accessible within a cluster only. I repeat, you want the application to be accessible within a cluster. So let's say there is a 2 pod here, 1 pod and 2 pod. Now this is the application, okay, and there is a 2 pod which we have for front end in this image. Here you see, this is the one. So this will connect to this one, right? But here the problem is, which one he should connect, here or here? Confused, right? So what to do? So we need one internal load balancer, correct? No? Agree? So what we will do, we'll create one load balancer here in the cluster only. This load balancer is internal, and this will balance this one, this pod and this pod. So if you want to configure this front end pod, you should connect to this one, and this guy will decide you should transfer to here or there. Make sense? Correct? Or this one also? Agree? Same thing. So this is a web server, and this is the load balancer, and this is the app server. So here it will go connect to the load balancer. This will decide where to transfer the traffic. Are you understanding?
Yes.
So now this load balancer, what we call it, guys? This load balancer, we call it in Kubernetes service. Very simple. This load balancer, we call it a service. Got it, all of you?
Yes.
Okay, so how do we create a service? That's the question. How do we create a load balancer? So for that, I am going to create a service. So kubectl get deploy. So you have a deployment, my deploy. How do we create a service? So first get SBC. Do we have any SBC? No. We have one SBC, which is a Kubernetes, which is the default for every clusters. Because of this, we are able to connect to the API server. But we have not created any service from our side. Okay. So what do we do? How do we create a service? So very simple. kubectl expose command. Okay. And I forgot the command exactly. So just give me a second. This will help me. Okay. So get SBC, get deployment, and what is the deployment name is mydev. So here I'm creating service using expose command for the deployment for the all the pod which belongs to mydev. And now this is a confusion. I always get confused and always forget. So this is the service port or container port. So this is a port, target port. Okay, so this is a service port and this is the container port on which the deployment balance will happen. So what you have to do, you can keep this service port anything, and the container port has to be 80 because pod is running on 80 port. Done. So kubectl get svc, and yeah, that was correct. So this is 8080. Now this is a service IP address, port number, but this service will load balance this load balance 10 pods right now. Why? Sorry, 15 pod. Let me show you. So describe this service. kubectl describe svc mydev. See here, 15 IP address you have it, and each of these IP address is load balancing 80 port. That means, in a simple way, I will hit. Understand this very simple way. I will hit this one, and this will redirect to one of the pod 8000 no? 8080, sorry, 8080, and this will redirect to one of the pod. It could be this one. Understood now?
Yep.
So can we check this? So let me check. Curl, I'm inside a cluster. Service is not accessible outside of the cluster. That's the reason I created an image. See, it's not there. What is the mistake? I have to use 8080. See, welcome to DevOpsSchool V1. Simple. I just run this command. Service got created, and I'm able to access within a cluster. Again, remind you, this service is accessible within a cluster only. Are you understanding now? Hello?
Yeah.
Madhu,
But,
Patrick, Anshita?
What is
but
the use?
ideally we should, yeah,
Yeah, tell
go
me.
ahead.
So what is the use of this load balancing? Is it like just like if we have an 10 pods, so like it's going to load balance like if we are requesting, then it will be accessing any one of them. Yeah.
Correct. Yeah, load concept of the load balancing is very simple. If
So
you have a one VM, one pod, no need required load balancer. But typically we don't have it one VM, right? We run 10 web server, 10
but
pods. So you need a
but
load
if,
balancer, correct?
but if we don't use the load balancer, then how it will be behaving without load balancer?
Then you cannot do that, no? That's the reason we have a load balancer. Without load balancer, you cannot run and consume multiple VM or multiple pod. Correct, no? This
So
dot dot is
you mean like
your VM, or it can be pod.
so you mean like without load balancer we can't access any port?
See, think simple. This statement is having double meaning actually. You said without load balancer we cannot access pod. Did we? And what is the answer? Actually, if you remember the port forwarding, remember port forwarding? Somewhere I did, correct now.
Yeah,
I was
yeah.
able to access the pod, correct, but only one pod, correct now.
Mm-hmm.
See, I'll give you a simple way. Think in a simple way, VM way. This is the VM1, VM2, VM3. Now, this is the person who wants to connect. Now, do you really want to connect the VM? So actually, you can hit the IP address of this directly and you can connect, no problem. If it is accessible, network is accessible. But you have here also, here also, here also. Now, if thousands of people are like this, and if you start hitting, it will hit either this one or three address. In real time, it will become 500 address. So people will get crazy. You remember 500 address for google.com? No?
Okay, yeah, got it for balancing, yeah, instead of, yeah.
So what we do, we set up one endpoint, one software, we call it load balancer, and we all hit here. We remember this one, load balancer, and then it will redirect one first traffic here, second user traffic here, third here, fourth here, fifth here, sixth here, seventh here, eighth here. So it will balance the load of thousands of people, correct now?
Okay.
So this is the load balancer. But typically you don't access the load balancer. So what do we do? Load balancer, we get certain IP just like this. See here. This is the IP of load balancer. What we attach, this IP we attach to DNS, domain servers. So you hit google.com, google.com will hit to the load balancer, public load balancer, and load balancer will hit to the one of the web server. Again, this continue fashion, it will go and next service, internal, and this will continue fashion like this, whichever the service we are. Got it?
Yeah, yeah. So public load balancer, it will go to the web server where the application server exists. From there, internal load balancer, that service there, it's going to connect, and from there is going to do load balancing for the port. Yeah,
Correct.
yeah. Okay.
Okay, so now coming back to the same image, see guys, so this service which I created is accessible only from the inside a cluster. But now you need an external service also, right? Here, because this is connected to the outside, right? So in this architecture, front end, we have to create external service. So there's one more service you needed. This will load balance this one and this one. Agree with me or not? Two service you needed, correct? All of you?
Two service means one will be external, correct?
No, no. Two service, two load balancer we needed. Why? Because we have a two kind of pod.
Okay.
Correct, no?
Mhm.
So let me create another one also. So here, history. I'll deploy one more. I'll change the image. It can be anything, but not a problem. And here, this I'll name it web. Okay. And I'll do one thing. App. I'll delete the existing one again. So you'll remember app. Okay. So I created get deploy. Okay. Sorry. QCTL. Get deploy. See, why? See here. You have app and web. I'll delete this one. Delete deploy web. Now, oh, it did not get deleted.
Deploy.
Deploy. Okay. So now you have a two types of application. By name you can understand this. It will be easy for you. Okay, two types of application. Now we need a two service also, right? So get svc. So I'll delete this service which I created. Delete svc. Done. So now in front of you I created two service. So how do we create it? Clear the screen. See here. Deployment name web and app. So two done. So now you have a two deployment in front of you. Okay. And two service. Are you understanding now? Simple.
Yep.
Now which one? Think simple. Okay. Always think. Don't focus on the commands too much. Focus on the theory and understanding. Which one need to be accessible outside? Tell me. Which load balancer? The front end or this one? Which one?
Front end.
front end. That means I have two service. One is app, which not required the exposing outside of the cluster. I said outside of the cluster. Which one you want to expose outside of the cluster? This
Front
one,
end, web
correct?
one.
Yeah. So now guys, let me ask you, how can you expose? So earlier, if you remember, I was so think about it. This guy will ultimate goal is understand that ultimate goal is to access this service. Agree or not?
Yes.
But the problem is the service scope is only cluster. Look at this here, clustered IP. This is not a public IP. It's a clustered IP means only internally accessible. So this guy cannot access. So what to do? Now technically, can this guy access the IP address of the node? I repeat, worker node, if publicly exposed. Yes or no? Worker node.
Yes.
Can he access? Yes, because that's the reason we are able to do SSH, right? Correct
Mm.
now?
Mm.
So yes, this is possible. But now you have a two worker. In real time, you have a 30 worker. So what to do? What to do? So first, let's fix one problem. So just like we did the port forwarding for the port, can we do one thing? When I hit to the worker IP address, it should it should transfer the traffic to the service. Got it? And see here the full flow. I will hit the public IP address of the node. This because this node IP address and service in the same network, cluster network. This will transfer the traffic to the service. Service will transfer the traffic to the pod of front end, and I will get access front end pod. How to do that? So that type we call it node port. Okay, what is that? There are three types of load balancer: service, scope. Scope. What is scope? So first one, default cluster. That means service, the load balancer you create, the scope is clustered. But this service, when you expose at the node, okay, expose at the node, just like port forwarding, we call it node port. This service will become a node port. Okay. So how can you create a node port? So actually, this service, this service which you have, you can convert to node port also through command line. I can convert this one. Okay, there is a way to patching actually, but I don't want to complicate. So instead of this one, I will create one more web, and here I'm creating, and here type node port. See, that's all I add, node port. Now this is already exist, so I have to name it hyphen name web1. See, kubectl get svc. Look at it very carefully. This one and web1, there is no difference. Both are load balancer, both are service, and both are load balancing the same deployment, same pod. But the only difference is, look at this here, it got exposed at the every node of the cluster. Every node of the cluster. So this is the service IP address, which is accessible internally, service port number, but this is a node port number. So if I go and access 302.87, let me show you. Where is that? Let me get the IP address. Public IP address and 302.87. See, I'm accessible. Got it? So what is happening? So some service, please hear me out. Some service, you want the accessibility outside. then the type, and if you want to access outside and the node port, then you have to specify node port. Node port will create a clustered IP plus node port together. That means if I put it in a simple way, the service got created and exposed at every node of the clustered is equal to node. Clear? This is accessible inside also, outside also, at the node port. Are you getting my points? So that means if you look at the image, this guy is able to connect directly at the node port, just like port forwarding we did this. But guys, you know what? Typically this will not be done. We will not hit the node port because you have a 2 worker in this image, but in real time you have a 30 worker. You can't remember the IP address. That is where that we need one external load balancer. What is external load balancer? What we need here, one load balancer. This load balancer will balance what? So this load balancer will balance the node. Remember, anyways, we are going to go to the node traffic, right? So this load balancer, who will create? Let me put it in this way. You have a pod. You want to load balance the pod. So for that, you have to create a service. But now you want to create a load. You have a node and you want to create a load balancer of node. Then who will create it? Think simple. Who will create it? Patrick, who will create it?
Sorry, can you come again?
See guys, you are not focusing actually. I am saying Kubernetes clusters is managing the pod. Now you want to have a too many pods, so you want to create a load balancer. Correct? So Kubernetes will create a load balancer, correct? Now you have a node and you want to create a load balancer for node, worker node, multiple VMs. So who will create this load balancer? Who's managing the VM?
Is
Cloud is
Kubernetes
managed.
already okay?
No,
Cloud like a
it's not.
VM. Mm,
It's managed by AWS and Azure, correct? No?
okay. Yeah,
Is it will be
like an
created?
external VM or a server we have to place.
It
I'm
will
saying
It will be
same.
outside Kubernetes.
Correct. Remember, concept, understand that. Pod is managed by Kubernetes. Node is managed by your AWS and Azure. Agree with me or not?
yes.
Again, repeat. Pod is managed by Kubernetes. Node is managed by
Cloud
AWS, Azure, Google Cloud. Cloud, yes.
service, yeah.
So if you want to create a load balancer, who will create it? AWS will create it.
Yeah,
Correct,
while
no?
creating VM, yeah.
Yeah? Agree? All of you? Conceptually?
Yeah.
Okay. So that type of the service, we call it load balancer. Load balancer. That kind of service. So what happen when you create a service type scope load balancer? What will happen? It will create a service cluster IP. Okay, that service exposed at node port, and then what will happen? Kubernetes will request AWS to create a external load balancer and add each worker of the cluster. These three things will happen when, please read it one more time in slow motion in recordings. Create a service, That service exposes the node port, and after that Kubernetes will request AWS or Azure or Google Cloud to create one external load balancer and add each worker of that cluster to LP. This all things will be done when you select the type is equal to load balancer. Whereas this cannot be done now because Kubernetes has no permission to AWS, that because I set up the cluster manually. But if you set up a EKS cluster, no, it will work. EKS, GK, EKS and all. If you go, you set up, it will work. So what will not work now? Only this will not work. I will show you manually. This will work. So can I do that? So guys, I'm creating the third types of service. Web 2. This is a load balancer. Okay, so here what I'm doing as per the image, if you look at this, what I'm doing, I'm creating one load balancer external. So see this service, I will hit here. My traffic will transfer to the node port to the service, which is internally, from service to the pod, front end pod, from the front end pod to the backend load balancer, and from backend load balancer to the backend pod. Did you see the traffic, whole traffic? Again, I'm telling you how the whole traffic will cover. I will hit the load balancer. Load balancer transfer the traffic to the node port. Node port will send the traffic to the front end service. Uh, front end service. Front end service will send to the front end pod. Front end pod sent to the backend service. Backend service to the application. Backend pod. There's a whole traffic. Okay. So what to do? So I create, enter. Look at this, qctl get svc. Look at it very carefully. Web 2 type load balancer. You got a clustered service? Yes. So if you access it, this one,
But you are
8080.
still in the cluster, right?
Uh-huh.
You are still in the cluster.
Uh,
I mean, you are inside the cluster, right? When you are creating the
so,
load balancer, how is it outside?
so the service will be there now, clustered. Without that, this will not work. This will not work. Correct?
Mm-hmm. Okay.
See here. See, from here I'll come here. From here I'll go to the node network. From the node to service, you need a service, this one also, right? Others, where will go?
Mm.
Correct now?
No, which load balancer you are creating right now through that command? The load balancer one that you have created.
Web,
Yeah.
yeah, web.
Yeah. So which is this node on, I mean, which is this component on that diagram?
Uh,
I
Internal
mean, you
load
have
balance.
created, yeah.
no,
So,
understand.
hmm,
So technically here I created 4 load balancer, okay?
correct.
Understand this.
Hmm.
This one is internal load balancer, okay?
Yes. Yes.
This one I created again internal,
Uh-huh. Hmm.
okay?
Which
Forget
is
about
service?
this one.
Yeah. Which is
Wait,
service,
wait, wait.
correct?
Service. These are service. Now I wanted this service was not accessible at the node port. So I
Hmm.
deleted. Let me delete in front of you. I want the service to be created which is accessible at the node port.
Hmm.
What I did, I
Correct.
created this, okay, but this is also I don't need it. Why? Because I want the service to be created at the load balancer level. Okay, so for that, this is the final service. Phase by phase, I am explaining to you. First, I explain clustered IP, then node port, and then last one is this one. Correct? So this, when you create a load balancer, you get a service IP address, port number. You also get a node port, and then you get load balancer also, which is pending state. Got it? All of you?
So the node port is not required if we have a load
How?
balancer.
If node port is not required, how do you go to from the load balancer to the this one?
But
See,
you have
again, look at
deleted
this
it right now, yeah?
flow. Look at this. Ultimately, you want to go to front end pod, correct? How you will travel? Think about it. Simple. From the outside, you'll go to the load balancer. This can go where? Node port. So you need a node port. That's what we have a node port here.
Okay,
From the
so
node,
right now, the types which you have choose before, it was a node put. Right now, the same, it is the type load balancer is doing correct. So
okay,
no,
let me, this is important.
Like a load balancer itself will have the node port, so we don't have to create like a node port
Correct.
separately.
Yes. Depends on your requirement. See, I'll put it in this way. If you need service, which is, I'm putting in a very simple way, which is accessible inside a cluster, type is use this clustered IP. Very simple one I'm putting up. Okay. If you need service which is accessible inside a cluster and node port, then your type is this one. And if you need a service which is accessible inside a clustered and node port and create external load balancer, three things together, then type is equal to load balancer. Now it's up to you to decide which type you need it for your application. Got it?
Yep.
So I wanted what? I wanted this last one. So this is created a clustered IP, node port, and this got pending LB because I told you Kubernetes is not integrated with AWS. If you set up a Kubernetes with EKS, AKS, GKE, it will be done. What to do now? No,
so
nothing.
I think
I'll
load, we have created the load balancer. So, so the cluster IPs, those both service also required here, or even
yes, of
if
course. It will not work, no? You see, it will not work.
okay,
See here. Again, from the load balancer, it go to the node port to the service, service to the pod, right? So if you
okay,
do not have all three, it will not work, right? Connection will not be made.
okay. So this three is required here.
Right. But guys, this is in pending state. Now, I feel I should not only talk, I should show you the uh, demo. That way you get a complete visualization. Though it's a paid service, but it's okay, worth to remove your confusion. So guys, what is happening? Clustered IP, this is created by Kubernetes. Node port, it was done by Kubernetes. But this is not done. So what I will do manually, I'll do that. I'll show you manually. This should have been done if integration is there, but manually let me do that. So go to the load balancer, okay, and load balancer. Oh my God, I have only load balancer automatically. See, this is what it happens. Last training, I showed some Artifactory demo for HA. So I created load balancer and forgot to remove it. So that will cost. So I'm creating a classic load balancer, simplest one. Create. This is a Kubernetes and it's internet facing or internal internet facing. Now select this all AJs and load balancer 80 port. What is the instance port? Tell me instance port. What is that? Quickly. What is the instance port?
800.
No,
Mm.
that's a service port.
Oh,
Internal. What is instance port?
yeah.
Your node port is this one, no? Instance node, worker,
Mm.
all are same. This is a port number where you hit, right? You let me
Yes.
remind
Yeah.
you.
Yeah.
Yes.
Here.
Mm.
Oh no, no, not this one. Somewhere I showed you. Here, look at this. Node port. Correct now?
Yes.
So this is the load balancer. You will put that to here. So this you can change it, load balancer, anything you can keep it, but right now 80 I am keeping it. Now, what is the index.html? That's okay. HTTP port. So it will hit here, and ping will be this one. Okay. Pin target. This is the one. Okay. And create. So I am creating load balancer manually. Okay. And this is the one. Now look at this. How many target instance you have to add that whichever the worker. So worker is here, master is here, and save it. Now I'll just check the health. So health check, and target instance. See, out of service. So the moment health check is completed, okay, target instance automatically will be in service. Just wait for it. I'm just health check was HTTP. Yeah, that's correct. See, in service. So now what is happening? I'll tell you. So this is the load balancer I created. Let me show in this image. This one I created load balancer manually. Okay. This I created manually, and I attached this node and this node manually. Okay. And here I had a node port already, so I configure it manually. This all will happen when you uh, uh, set up the cluster and EKS. So now guys, if I hit the load balancer, which is the load balancer? IP address or DNS, where is that? Here it is. Look at this. So now this one, remember, this one I hit anywhere in the world, it should take me to the node, and from the node to service, and service to the pod. Understood now? Let me show you. See, so this is going to where? To the node port. From node to the service, service to the pod where application is running. Got it? Hello?
Yes, yes.
Okay. Let me show you one more step, so it will become a complete flow, because this will get it. So, but guys, do you really hit the load balancer? Patrick, do you really hit the load balancer directly, user end user? Tell me
No.
what we hit. Tell me.
This is the load balancer here.
So this is the load balancer. Do we really hit the load balancer directly? What we hit?
No. No, we
What we
don't.
hit?
It should
We hit
go through
DNS, right?
DNS, yeah.
What is the DNS? Some domain, right? Correct? Na?
Mm.
www.google.com, DevOpsSchool.com, Rajesh.com, whatever it is. We hit the DNS. DNS transfer the call to the load balancer, load balancer to the node, node to the service, service to the pod. Are you understanding?
Yeah.
But yeah, Anshita, Madhu,
Yes.
let me
Yes, yes.
map this one also, so you'll have a complete visualization. Go to the DNS server, okay, and I'm showing you the DNS server. This is my DNS server, real production ready. Okay, so that we have a complete flow. Others, let's do one thing. Just give me a few seconds. I'm going to the my DNS because that is safer. Okay, this is my domain. Okay, I bought it at GoDaddy. Okay, so here is your DNS server. Edit DNS. Now this is a DNS server, but you know what? This is my main domain. If I map this main domain, the site will be redirected to everything, which I don't want. It's a production, right? Uh, uh, why it's not coming? I think have a load on the server, I guess. Now it came, correct? So this is my own domain. I don't want to redirect. So what I will do, just for the demo, I will redirect. I'll create one more subdomain, demo.rajeshkumar.xyz. Okay. So let me create this one. So go to the DNS server and demo. We have it. No, we have it. So let me create one demo, a record demo, and here I have to give the load balancer. So where is the load balancer? Here it is. See, this is the a record. So what we do this, but the problem is this DNS is not accepted here. This DNS is not accepted. It required IP address. So what I'll do, I'll just cheat IP address ping -a IP address. I'll get it. It's giving IPv6. Just just a second. That's the issues with the AWS. Azure has no issue. They give you the IP address directly from DNS. Yeah, these are two IP address given. One of which is sufficient for time being, for demo. Okay, I'll go and edit this. Done. Now this will take a couple of seconds to impact. Now anyone in the whole world will hit on the demo.rajeshkumar.xyz. It will transfer the traffic to the load balancer, load balancer to the node port to the Kubernetes service. This is from here only that you are getting inside a cluster network. See, this is the network which is inside a cluster, and till here you are this is a AWS network, VPC AWS network. This is a Kubernetes network. There's a Kubernetes network, and this is your DNS outside. That's my global network. Global network. This one global network. Okay. This is an AWS VPC network, and this is the Kubernetes network. Three network. You see, this is the global network, AWS VPC network, Kubernetes network, and this is the name records. So now, if you hit this one, see. Right now it's not coming to me because maybe cache. Can you try from your side, because India is very fast in that case. Indian network is very good actually compared to other countries. Can you try hit this? Are you able to see? Anyone?
It's not coming.
It's not coming. Maybe it will take some more time.
Yeah. So let me check IP address was correct or not meanwhile, because it takes some time. 173, correct? Let me hit the IP address directly.
Why we are
See,
getting
IP
two IP addresses?
basically it's a managed service. Load balancer is managed service, so they give you the two IP address. But typically, we create a same C name record, so that's a different discussion. But yeah, can you check now? You guys are, I mean, India will have a faster cache. Patrick, can you try? Maybe US also will have a faster cache. demo.rajeshkumar.xyz.
Yeah, I'm trying.
Try with HTTP. Oh, mine is going to HTTPS by default. I don't know why. Oh, no, HTTPS only. Try HTTPS. Yeah, that's correct. Oh, no. Wait.
It's
This is a
automatically
my.
resolved.
No, that's a problem with my server setting. All the traffic which is hitting to the rajeshkumar.xyz, it is hitting to HTTPS. That's the problem. But I want force to HTTPS. How to force? Force to HTTP. This is server setting actually. Okay, that's a problem. I cannot change right now. But what we do? Uh,
It's not working actually.
Yes, hold on. So let me try first. Once again, this is working, and demo.rajeshkumar. Mine is DNS Pro. Let me check my DNS one more time. Oh, my bad. The DNS was not a demo. I put it up some way by mistake. This one. That was my bad.
Demo.
Yeah, now it's working. Okay, so by mistake it was my not demo actually. Got it? So now you see the whole traffic is transferring. You see, human will hit what? Domain. Domain will transfer to what? Load balancer. Load balancer will transfer to what? Some port of the node, and node of the port to the service IP address and port number. From service IP address to the container pod IP address, and pod has a container. Whole traffic will be served. This is an external one. But for the internal one, you don't need all these things. So now you understood how it works all together.
Yeah.
Okay, so guys, you have to practice it. I know first time you will not understand, but yeah, you have to practice it.